Hello friends, in the last lecture we had a detailed discussion over normal strain. In this lecture we will take some examples of normal strain. Example 1 says that a short post constructed from a hollow circular tube of aluminum supports a compressive load of 250 kN. The inner and outer diameters of the tube are D1 is equal to 9 cm and D2 is equal to 13 cm respectively, and its length is 100 cm. The shortening of the post due to the load is measured as 0.5 mm. Determine the compressive stress and strain in the post. Disregard the weight of the post itself and assume that the post does not buckle under any load. Let's go for the solution, students. First of all, let's write the given data. The load is given to us as 250 kilonewtons. The length of the bar is equal to 100 centimeters. Delta L is equal to 0.5 millimeters. And we also have been given the diameters D1 as 9 centimeters and diameter D2 as 13 centimeters. First of all, let's find out the area of the cross section. The area of the cross section, which is equal to A, is nothing but pi upon 4 into D2 square minus D1 square, which is equal to pi upon 14 into 13 centimeter square minus 9 centimeter square, which gives us the answer as 69.08 centimeter square. Therefore, the compressive stress in the post is sigma, which is equal to P upon A, which is nothing but 250 into 10 to the power 3 Newton, the whole upon 69.08 into 10 to the power minus 4 meter square, which gives us the answer as 36.19 megapascal. Therefore, the compressive stress in the post is given to us as sigma is equal to P upon A. Let's write it down. We know that P is nothing but minus 250 into 10 to the power 3 Newton, and area has been found out to be as 69.08 into 10 to the power minus 4, which gives us the answer as minus 36.19 megapascal. Also, the compressive strain is epsilon, which is equal to delta upon L. So, the compressive stress is given to us as delta upon L, where delta is 0.5 into 10 to the power minus 3. And this answer comes out to be as 0.5 into 10 to the power minus 3. In the second example, we have a bar of steel with a length of 100 centimeters, which is subjected to a tensile load of 20 kilonewton. Due to this load, there is an extension of 0.1 centimeter in the length. If the diameter of the bar is 10 millimeter, then find out the change in the diameter. If the Poisson's ratio for the material of the bar is 0.25. Let's look into the solution part. Let's write down the given data. The length is given to us as 100 centimeters. The load P is given to us as 20 kilonewton. The diameter of the bar, which is small d, is given to us as 10 millimeters. The change in the length, which is delta L, is 0.1 centimeters. Also, the Poisson's ratio, which is mu, is 0.25. We have been asked to find out delta D. We know that the Poisson's ratio mu is nothing but lateral strain upon the linear strain. So let's write it down. Mu is equal to delta D, the whole upon D, the whole upon delta L upon L. We know that Poisson's ratio mu is given to us as lateral strain upon linear strain, which is delta D upon D, the whole upon delta L upon L. Hence, if we write down the values, we get 0.25 is equal to delta D upon 10 the whole upon 0.1 upon 100, which is nothing but delta D upon 10 into 100 upon 0.1. On calculating, we get 0.25 is equal to delta D into 100. Hence, delta D is equal to 0.0025. This is the answer for the question. Hence, delta D is equal to 0.0025 millimeter. Let's go for the next question. It states that an air-filled rubber ball has a diameter of 6 centimeters. If the air pressure within it is increased until the ball's diameter becomes 7 centimeters, determine the average normal strain in the rubber. We also have been given that DO is equal to 6 centimeters and D is equal to 7 centimeters. So let's find out the solution. We know that the average normal strain is equal to epsilon, which is equal to pi into D minus pi DO the whole upon pi DO. Let's write it down. Epsilon is equal to pi D minus pi into D0 upon pi D0. The D0 is nothing but the outer diameter. We have been given as pi D as 7 and pi D0 is equal to 6, the whole upon 6. Hence, we get epsilon as 1 upon 6, which is equal to 0.167. In the next question, we have been given a thin strip of rubber has an outstretched length of 15 millimeter. It is stretched around a pipe having an outer diameter of 5 millimeter. Determine the average normal strain in the strip. Let's go for the solution, students. As per the given data, LO is equal to 15 millimeters and length, as we know, is nothing but pi D, which is pi into 5. We know that epsilon is equal to L minus LO the whole upon LO. We have got L to be as 5 pi and LO as 15. And let's write it down as 5 pi minus 15 the whole upon 15. So epsilon is equal to 0.7 the whole upon 15, which is equal to 0.046. In the next example, we have been given the rigid beam which is supported by a pin A and wires BD and CE. If the load P on the beam causes then end C to be displaced by 10 millimeters downwards, determine the normal strain developed in the wires CE and DE. The solution has been given as follows. As the deflection at C is 10 millimeters, so after extension it will look like a triangle. So apply similar triangle property to get elongation at point B. Hence, we can say that delta L BD the whole upon 3 is equal to delta LCE the whole upon 7. Let's write it down. Hence, we get the value of delta LBD as 4.286 millimeters. Now, for epsilon CE, we know that epsilon CE is equal to delta LCE the whole upon L. Therefore, epsilon CE is equal to delta LCE the whole upon L, which is equal to 10 upon 4000, which gives us as 0.00250 millimeters. Similarly, for epsilon BD, we get delta LBD the whole upon L, which is equal to 4.286 the whole upon 4000, which gives us the answer as 0.00107 millimeters. Now let's look at the next example. The center portion of the rubber balloon has a diameter of D is equal to 4 mm. If the air pressure within it causes the balloon diameter to become d is equal to 5 mm, determine the average normal strain in the rubber. Let's look at the solutions. We know that epsilon is equal to d minus do upon do. Let's write it down. We also have been given d as 5 and do as 4. Hence, the value of epsilon comes out to be as 1 upon 4, which is 0.25. In the next lecture, we take some examples of normal strain. In this lecture, we took some examples of normal strain. In the next lecture, we will discuss the shear strain and will take some examples of it. Thank you for watching, students.